All right, for calculating step 8, part A is time to reach terminal velocity. So the force of drag is given as AV plus B. Newton's law is mg minus force of drag. This can just be written as ma, or m times dv dt. Dv over mg minus av plus b is equal to 1 over m dt, and to get time, you just take the integral of dt. So you integrate both sides, you get dv over m, the integral of dv over mg minus av plus b is equal to the integral of 1 over m dt. So now for doing it for each one, the sphere, you have mass, you have slope, and you have intercept. So m times g is given there. And this is just plugging in all the numbers, simplifying, and yeah, solving for t or time. So we come up with these equations. I'm just going to scroll through so that you can see. I wrote out the first couple for each step, and then just simplified it down so I didn't have to write them all out. But yeah, so here's for sphere, and then golf ball, cylinder, the other orientation of the cylinder, the large face of the block, and the small. And then for 8b, distance to reach terminal velocity. So here we just have to rewrite the acceleration equation as v times dv dx, and then solve for dx on one side. Once we do that, we can take the integral of each side just to get the distance x. So we get this equation here for x of v, and then we have all of our information that we're just plugging in and simplifying all the way down. So this is for sphere, golf ball, cylinder, the other orientation of the cylinder, large face of the block, and the small. And then for 8c, the terminal velocity at each profile. So at terminal velocity, the net force is equal to 0. So mg is equal to f drag, which is equal to acceleration times terminal velocity, or not acceleration, I'm sorry, slope times terminal velocity plus your y-intercept. And then you're solving for v of t, which is terminal velocity, and you get mg minus b over a, and just plug and chug. So here are all my velocities for sphere, golf ball, 2 orientations of the cylinder, and 2 orientations of the block. And then 8D, determine the time it takes to reach 50%, 90%, and 99% of terminal velocity. Using the above equations with the LNs, especially inside the equation, some of them were turning up to be negative, and it was kind of funky. So I found this equation, and I just used TV is equal to negative ma over ln times 1 minus v over v of t, and plugged everything in here for the sphere, and got my time it takes to reach terminal velocity, or 50%, 90%, and 99% of terminal velocity here for the sphere. For the golf ball, the 2 orientations of the cylinder, and the 2 orientations of the block. And then part 8E, distance to reach a percentage of Terminal velocity, same percentages, 50%, 90%, 99%. Using this position equation, just plug in and simplify all the way down. And we get this for our distances to reach the percent of terminal velocity. So for a sphere, for the golf ball, for the two orientations of the cylinder, and then for the two orientations of the block. And that's everything.